Hello, welcome back to another episode of Math with Haas. You're watching Precalculus, Season 1, Episode 11, and this is Example Video 1. So, in Episode 11, we talked about two models for exponential growth, and now I want to talk about an extra example to help you with question 3 on the Google Forms. Now, here's how we'll tackle it. We'll just dive right in. In order to answer this question 3, we have to use a particular technique. So, suppose there is a bacteria population that was about 400 at 15 minutes, and oops, yep, I did put 2 in. And how about how about 600 at, let's call it 70 minutes. So then our first question is going to be, what is the initial population? What is the population at about 2 hours? And then how long will it take for the population to reach 500,000? Alright. So, to approach this question, I want to note that let's just start with making a list of what we don't know. So in this area here, we are not given the initial population, you are not given a rate, you're not given a doubling time. For our equation, we had P equals P naught E to the RT, P equals P naught 2 to the T over D. Alright, so P naught, R, D, those are all unknowns. Now, I'm not going to use this equation, I'm going to use the one with the exponential base E, the way I've numbered them. And so when we look at this, we don't know P naught, we don't know R. What do we know? Well, we're given this information and this piece of information. So this is going to be two coordinate system, or I should say 2 points. Okay, so if you think of a XY point, you know, X comma Y, we could think of it in that manner. So just looking at this, we have population was 40 at 15 minutes. That means P is going to equal 40 when T is equal to 15. Similarly, P is equal to 600 when T is equal to 70. So we can generate two equations. We have 40 is equal to P naught E to the R times 15, and we have P naught of just P is equal to, oh yeah, we know what P is. So we have 600 is equal to P naught E to the R times 70. So we have these two equations that we can formulate based on the fact that we know what T and P are, but we don't know R or P naught. And now my technique that I want to show you is the following. So I'm going to rewrite our equation here with the larger values. And what I'm going to do is put the other equation right below it. And in order to solve this system of equations, so I formed a system of equations because we have two unknowns, P naught and R. That always will entail that you need two sources of information, i.e. two equations, in order to properly solve for both quantities, P naught and R in this case. So I wrote our equation with the larger numbers on top, and then the equation with smaller values on the bottom, and I'm going to actually divide the two equations. So by dividing the equations, on the left here we have 600 divided by 40, so we can think that's the same thing as 60 over 4, so think 30 over 2, or yes, 15. Alright. And then when we look at the right side, the P naughts will just cancel out. So you're left with 15 is equal to e to the 70r over e to the 15r. Now, this quantity on the right is the same thing as e to the 70r minus 15r. So now we have 15 is equal to e to the 55r. Now notice here that now we just have a nice exponential equation that we can solve. So I'm going to take natural log of both sides, and our exponential and logarithm on the right side will cancel out. I picked natural log because that's log base e, so we can use this property, natural log of e to something. So I'll just give out x. And now we just have natural log of 15 is equal to 55r. We could divide out the 55 and get r is equal to natural log of 15 over 55. So looking at this, the key technique here was recognizing we can take the equation, divide by a second equation, and doing so here actually simplified rather nicely. In the end, we just have this very basic exponential equation that we solve to get r. Without doing this technique here, it would be a little bit more complicated solving, but you can work it out through substitution, taking one of these equations, solving for P naught, and then plugging what you have into the other. I think that would be a lot more work though. Alright, now that we know what R is, we can answer the first question, what is the initial population? So to answer that question, what I'm going to do is simply take my R value here and plug it back into this equation or this one. Doesn't matter which of the two equations I plug it in, I'll just plug it back into this one. So we have 40 is equal to P naught e to the r times 15. We know what r is, so I'm not going to write it out, because that is it's a little bit to write out. I'm just going to make a note in my calculator what it is. So what I'm going to do is store this in memory slot R. Oops, I forgot to actually store that in memory slot R. There we go. So now I have that prepped. Now I'm going to work on solving this. I need to solve this for P naught. So we just need to divide out the e to the r 15. Alright, so dividing that out, we get P naught is equal to 40 over e to the 15r, and we know all the quantities on the right, so we just need to plug this into the calculator, and then we have 15r. and that gives us 19. Alright, so our initial population is 19, approximately 19. I rounded down because you can't have partial bacteria. However, I am going to say this 19.11, etc. So I'm going to store this in memory slot P for population. So there's our initial population saved, and let's look at our next question. So, what is the population at 2 hours? Alright. We need to make one note before we dive in. So, population at 2 hours. So notice that I give time units in minutes and in hours. So the easiest thing would be to take our 2 hours and say that's 120 minutes. Otherwise, you would have to convert these values into hours, which would have been a lot more work. So just taking that 2 hours and multiplying by 60 be much easier. So now we can set up our equation. So in this case, we're looking for what does P equal at T equals 120. And to do that, we can just say, well, P has to equal our P naught value, e to the r times 120. We know what P naught and r are, so we can just plug this all in. So here's our P times e to the 120 times our r. So P will equal 7,035. Now just round it down because again, you don't want to have a partial bacteria even though it's 0.98, almost 0.99. Alright. So then our third question. Oh yeah, it was at 500,000. So question is, if P is equal to 500,000, what does T equal? So we can set up our equation the following way. We have 500,000 is equal to P naught e to the RT. Oops, that doesn't look nice. Let's make this better. P naught e to the RT. So we need to solve for T now. So I'm going to divide out our P naught. So we have 500,000 over P naught is equal to e to the RT. Now you probably wonder why I just didn't calculate that value right here on the left in the calculator. And it's because I'm just going to save it for the very end, plug it all in at once. Because if I plug in that P naught value now, remember it was 19.11, etc. That's not an easy value, and if we round, we can lose accuracy. So to save accuracy, I'm not going to round until after I just plug everything in to the calculator at the very end. So now we have our exponential equation isolated. I am going to or I should say our exponential function here on the right. Now that is isolated, I am going to take the log of both sides, so natural log of 500,000 over P naught will equal natural log of e to the RT. Now, by our property, we know that the exponential and the logarithm will cancel each other out because they are the same base. So that leaves us with the following. So divide out the r and we get t is equal to the natural log of 500,000 over our P naught is equal to our r value. So we can plug that in now. 500,000 divided by our initial population. And that entire quantity divided by our r. So that tells us that t must equal 206.6 minutes. So it's almost 3.5 hours. If we divide by 60, 3.44 hours. Alright. So to review, our key strategy in solving this. So we're given essentially two coordinates. We're told what at a particular value for the independent variable, what the dependent value is. So when t was 15, p naught is, or p was 40, similar here. So we have pretty much two coordinate pairs. And to figure out some more information, we had to set up two equations. We had two unknowns based off this equation here. Since we had two unknowns, we need to set up two equations. So once I set my two equations, the way to easily solve this is I just took the top equation divided by the bottom equation, which simplified to this really nice one here, which we could then solve to get r. Without this technique, your life would have been a lot harder, so keep this technique in mind when you're solving equations. It's a very valuable one. If you enjoyed this episode, please subscribe to our YouTube channel, check out our Patreon page, and thank you for joining our math party. I will see you next time.